This video will explain how a firewall enhances network security. Firewalls evolved as vital shields in our digital world, safeguarding against evolving online threats, ensuring a safer online experience for all. Before going into details, let's begin by exploring the fundamental concept of firewalls. What is a firewall? A firewall is a network security device or software that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Its primary purpose is to establish a barrier between a trusted internal network and untrusted external networks, such as the Internet. Firewalls can be implemented in both hardware and software forms. That is, a firewall in computer networks acts as a digital barrier between an internal network and external networks. It controls the flow of data in and out of a network based on predefined security rules. Okay? Figure 1 shows how a firewall works. In Figure 1, the external network represents the untrusted networks such as the Internet. As mentioned earlier, the firewall is the protective barrier between the external and internal networks, and the internal network represents the trusted network within an organization. The firewall monitors and controls the traffic between the internal and external networks, enforcing security policies to prevent unauthorized access and ensure the safety of the internal network. Next, we will discuss how a firewall enhances network security. Key ways in which a firewall enhances security include 1. Packet filtering, 2. Stateful inspection, 3. Proxy services, 4. Network address translation NAT, 5. Virtual private network VPN support, 6. Intrusion detection and prevention, 7. Logging and auditing. First of all, let's explore the packet filtering, that is a fundamental role of firewalls. Packet filtering. Firewalls examine data packets as they travel through the network and make decisions based on predefined rules. These rules act as a sort of digital bouncer. These rules specify which packets are allowed and which are denied, depending on factors like source and destination IP addresses, port numbers, and the type of protocol being used. This means in our digital world, firewalls act like traffic controllers for our data. They look at each packet of information moving through the internet and decide if it is allowed or not, just like a bouncer at the door. They follow rules, checking where the data is coming from, that is source, where it is going, so that is a destination, and what kind of data it is. If everything fits the rules, the data gets the green light. If not, it is stopped at the door. It is a digital bouncer, making sure only the right data gets into our network. Okay. Now, let's explore stateful inspection, a more advanced function of firewalls. Stateful inspection. Unlike simple packet filtering, stateful inspection, known as dynamic packet filtering, keeps track of the state of active connections. It allows or blocks packets based on the context of the traffic, ensuring that only legitimate connections are established. That is, think of stateful inspection as the intelligent processor within a firewall. Okay, rather than just analyzing isolated data packets, it retains information about ongoing connections. This allows it to evaluate the broader traffic context and make informed decisions about permitting or blocking data packets. By considering the continuous relationship between devices, stateful inspection adds an additional layer of sophisticated security, ensuring only legitimate connections are established within your network. Okay. Now, let's explore proxy services, a pivotal function of firewalls. Proxy services. Firewalls can act as intermediaries between internal and external systems. Proxy servers within the firewall's framework receive requests from clients and relay them to their intended destinations while concealing the client's identity. This fundamental mechanism fortifies internal systems by preventing direct interactions with external servers. To illustrate, proxy services operate as digital intermediaries. When internal systems seek external communication, the firewall assumes the role of a proxy server. It receives client requests, redirects them to their destinations, and ensures the client's identity remains concealed. This strategy safeguards internal systems by establishing an extra layer of protection and anonymity in digital communications, preventing direct contact with external servers. Okay. Let's explore network address translation, NAT. That is another way firewalls enhance network security. Network address translation, NAT. Firewalls often use NAT to modify network address information in packet headers while in transit. This makes it more challenging for external entities to determine the internal network structure, adding an additional layer of security. Essentially, network address translation, NAT, acts as a disguise for your digital identity within the firewall's framework. By altering address information in data packets during their journey, NAT transforms the internal network structure into a puzzle for outsiders. Actually, this not only adds a protective layer but also serves as a virtual camouflage, preventing potential threats from mapping out and directly targeting your network's devices. Okay. Moreover, let's discuss virtual private network VPN support. Virtual private network VPN support. Firewalls can facilitate secure communication over the internet by supporting VPNs. VPNs encrypt data traffic, ensuring that sensitive information is secure while being transmitted between various locations. Here, what do you understand by virtual private network VPN support? Firewalls play a pivotal role in ensuring secure internet communication through their support of virtual private networks VPNs. In addition to encrypting data traffic, VPNs contribute significantly to securing remote communication, guaranteeing the confidentiality of sensitive information during transmission between different locations. This integration significantly supports overall cybersecurity measures, fortifying networks against potential threats and enabling the secure exchange of data. Okay? Now, let's briefly explore intrusion detection and prevention. Intrusion detection and prevention. Some firewalls incorporate sophisticated intrusion detection and prevention capabilities. These systems continuously monitor network traffic, scrutinizing it for any signs of suspicious or malicious activity. When such activities are detected, these systems can autonomously take proactive measures such as blocking or mitigating potential threats to safeguard the network. Here, what is meant by intrusion detection and prevention? Certain firewalls are equipped with intrusion detection and prevention capabilities that act as vigilant guardians. For example, or for instance, imagine a firewall system monitoring incoming network traffic and recognizing a series of repeated failed login attempts from an unrecognized source. Upon identification, the system promptly blocks further access attempts from that source, preventing a potential security breach. These systems continuously analyze and respond to network activity, proactively safeguarding against various intrusion attempts, thereby strengthening or supporting the overall security of the network. Okay? As previously highlighted, among the key ways firewalls enhance network security, logging and auditing stand out prominently. Logging and auditing. Firewalls diligently maintain comprehensive logs of network activities, serving as a crucial repository of events for administrators. This proactive measure provides invaluable insights for monitoring network security, investigating incidents, and notably identifying and addressing potential vulnerabilities. Elaborating further, firewalls meticulously record and preserve network activity in logs, presenting administrators with a detailed event history. These logs play a pivotal role beyond mere observation, actively assisting in the continuous monitoring of network security. They serve as early warning indicators, aiding in the quick investigation of incidents and proactively identifying potential vulnerabilities before they escalate. By leveraging these logs, administrators can take proactive measures to strengthen the network's defenses, thus enhancing the overall cybersecurity posture. Okay? Now, we will conclude with a brief summary in this context. In summary, a firewall enhances network security by governing the flow of data between an organization's internal and external networks. This control prevents unauthorized access, thwarts malicious activities, and mitigates potential security breaches, ensuring data integrity. Summarizing, a firewall plays a pivotal role in strengthening network security by vigilantly managing and overseeing the exchange of data between an organization's internal network and external networks. This proactive stance not only prevents unauthorized access and malicious activities, but also mitigates the looming threat of potential security breaches, ensuring the integrity and confidentiality of sensitive information. Okay.